Volt company generates and sells electricity. It generates Volt company generates and sells electricity. It operates two types of power stations, nuclear and wind. The cost and the output of the two types of power stations are detailed below. Nuclear station can generate 9,000 gigawatts of electricity in each of its 40 years of useful life. Operating costs are 486 million per year. The operating cost include a provision for depreciation of 175 per year to recover the 7,000 million cost of building the power station. Each nuclear station has an estimated decommissioning cost of 12,000 million at the end of its life. The decommissioning cost relates to the cost of safely disposing of spent nuclear fuel. A wind station can generate 1750 gigawatts of electricity per year. It has a life cycle cost of 55,000 per gigawatt and an average operating cost of 40,000 per gigawatt over its 20 years of life. What is the life cycle cost per gigawatt of the nuclear station? Okay, so the first part is what is the life cycle cost per gigawatt of the nuclear station. So in a nuclear station can generate 9,000 gigawatt of electricity in each of its 40 years of useful life, and the operating cost is 486, and the operating cost includes the depreciation cost. So we will have to exclude the depreciation cost from the operating cost, which is so it will be the operating cost given is 4,86 million. You subtract the depreciation, which is 175 million, and this is the net operating cost, which is 4,86 minus 1,75. This is 311. Now this 311 is for 1 year, and this the station will operate for 40 years. So for 40 years, operating cost for 40 years will be 311 into 40 is 12440. So this is the cost which has been incurred for 40 years. Each nuclear station has estimated decommissioning cost. We will add the decommissioning cost as well. Which is 12,000. And then we will get the total cost. Are we missing something? Yes, there is 7,000 also cost involved in building of the power station. So cost of building power station 7,000. Okay, so this was life cycle cost per gigawatt. So the total gigawatts of electricity in each of its 40 years is 9,000. Each of the 9,000. So for each year, electricity for 40 years will be 9,000 into 40, 3,60,000. Because in this question it has not been given cost per gigawatt per year, so per year concept is not there, therefore we will have to calculate the entire cost for 40 years, and it will be divided by the electricity for 40 years. So the cost per unit is 31440 divided by, and this is in million. Okay, let me divide it, and then I'll this all cost is in million. Let me divide it, and after that I will multiply it by 1 million. I get the answer as 0.08733. I will multiply this by 1 million, and the thing I get is 87,333. So this is the cost per unit of gigawatt. I think C is the answer. B, it is saying which of the following will decrease the total life cycle cost of nuclear station, increasing the useful life of the station. If I will increase the useful life of the station, for example, if the useful life will increase from 40 to 45, my operating cost for 40 years, for 45 will also increase. So if the operating cost will increase, will it reduce the total life cycle cost? No. So the option 1 is incorrect. Reducing the decommissioning cost will definitely reduce my life cycle cost, so B is the correct answer. How would the disposal cost of spent nuclear fuel will be categorized in environmental management accounting? A preventive cost, a detection cost, or an internal failure cost, or an external failure cost? An internal failure cost. Environmental internal failure costs are those costs incurred from performing activities that have produced contaminants and waste that have not been discharged into the environment. We are told decommissioning cost is incurred by Volt company as a result of its activities. It relates to the cost of safely disposing of spent nuclear fuel, and by safely we may deduct that the fuel has not been discharged into the environment. It is being disposed in a safe manner to ensure that it does not become the cost borne by the society as a whole. If Volt company sets a price to earn an operating profit margin of 40% over the life of a wind station, what will be the total lifetime profit per station? Total lifetime profit per station. So a wind station can generate 1750 gigawatts of electricity per year. It has life cycle cost of 55,000 per gigawatt and an annual operating cost of 40,000 per gigawatt over 20 years life. Over 20 years life. Okay. And the operating profit margin is 40%. So what is, if my operating profit margin is 40% and my average operating cost is 40,000 per gigawatt, but over here it is the total life cycle cost is given. Okay. What we have been given is the operating cost only, we are not given the total cost. So for calculating total cost, if my operating profit margin is 40%, then my cost is 60%. Cost is equal to 100 minus 40%, that is 60%. And so total cost would be, this is the operating cost percentage. So the total cost will be 40,000 divided by 60%, and I would get total cost, which is 66667. So this is the total cost. And what was the lifetime cost? Life cycle cost, life cycle cost was 55,000. Okay, if the life cycle cost is 55,000, so I can get lifetime profit, which is so this is not the cost actually, this is the revenue. Okay, let me just do it all over again. So operating cost, operating profit was given 40%, and we have been given that the operating cost is 40,000. Operating profit percentage is 40% and cost is 60,000. So cost plus profit, that is 40% of X, cost is 60. Okay, so even I'm getting confused now. The thing is that operating cost is 40. Alright, if the operating cost is 40 and the profit margin is 40%, so I will have to calculate the revenue. So the revenue would be 100%. Revenue would be 100% if my profit is 60%, and I would get the cost, sorry, 40%, so I will get the cost. So this, for calculating revenue, I will have to divide the cost by, the cost is given 40,000 and not 60. This is where the confusion is coming from. The cost is 40,000. So the revenue is 66667. Yeah. So if the revenue is this and the life cycle cost is 55, I would get the difference as this much as profit, but I have to calculate this, the total lifetime profit per station. So I will have to multiply it by the gigawatts each station is producing, and this is for 20 years. So I will have to multiply it by total lifetime cost is 11667 into 20 into 1750, which is 40833. Okay, yeah, so I will convert into millions only. So this is the answer. So what have I done is, this is a bit confusing. So in this, a wind station can generate 1750 gigawatts of electricity per year. It has a life cycle cost of 55,000. So a life cycle cost has been given of 55,000. So the entire life cycle cost has been given. So in order to calculate the lifetime profit, we will have to calculate the life cycle cost as well. But over here the life cycle cost is not given, only the operating cost has been given. If I will find out the total revenue, sorry, the life cycle cost is given and the operating cost is given, but I do not have the revenue. So if I will deduct the lifetime cost from the total life cycle revenue, I will get the profit. But how will I calculate the life cycle revenue? I can calculate that with the help of operating profit margin, which has been given to me. So the operating profit margins the formula for that is operating profit upon sales, that is the revenue, is equal to 40%. So the sales revenue would be 40,000, but this is the cost. So but this is the cost and not the operating profit. That is another challenge. So how can we calculate the operating profit? I can simply divide 40,000 by 60 and I will get the operating revenue, that is 6667. So this is my operating revenue, and from this operating revenue I can deduct the cost and I can get the profit. So what is the answer? It is the last option, which is the second last option. I think B is the answer. Which of the following are benefits of life cycle costing for Volt company? It facilitates the designing out of cost at the product development stage. It can encourage better control of operating cost over the life cycle. It gives a better understanding of the causes of the overhead. Does it gives the understanding of what are the causes of? I really doubt, but let's see. It provides useful data for short-term decision making. This is actually not useful for making the short-term decision making. Life cycle costing is not used for short-term decision making. So fourth is incorrect. And if I see option C and D are having fourth option, so definitely C and D are not the correct options, and now we have only A and B. In A and B, I'll read out again. It facilitates designing out of the cost at the product development stage. I think this is correct. The second statement is it can encourage better control of operating cost over the life cycle. Yes, it gives a better understanding what causes the overheads. So this can be in the ABC costing, the third part. So I think 1 and 2 are correct, and so B is the correct answer.